In this problem, we have some radicals with index other than 2. So we've got cube roots instead of square roots here. And we want to solve for a variable that's inside these radicals. In this case, we've got a cube root on one side, a cube root on the other side, and nothing else to worry about. So we can just undo the cube root by choosing to cube both sides. So I can cube here. As long as I do the same thing over here, it should be okay. Although having said that, whenever you raise both sides of an equation to a power, it's possible to get some answers that don't really work with the original equation. So if we get an answer here, we'll need to plug it back in and double check that it actually works. But for now, the cubing will undo the cube root. So we'll have 4y plus 15 on one side, and we'll have 6y plus 5 on the other. So that looks pretty easy. Let's just subtract 4y to get the variable just on one side. So this will give us 15 equals 2y plus 5. And then we'll subtract 5, and we get, I'll rewrite it in the other direction, 2y equals 10. And then we divide by 2, and we get y equals 5. So this is a possible solution. We can verify it by plugging it back in here. So 4 times 5 plus 15, and then take the cube root of that, has to equal the cube root of 6 times 5 plus 5. Okay, well 4 times 5 is 20, plus 15 is 35, so this is the cube root of 35 on one side. And 6 times 5 is 30, plus 5, cube root of 35. So this does check out. The cube root of 35 equals the cube root of 35. So y equals 5 is a valid solution. So that's a little bit of work with these radical equations where the index is greater than 2.